in differential equation. See?
Yeah.
Yes, of course, the derivative will be there in the whole equation. Correct? So in differential equation, the equations will be like this. Let's suppose double derivative is also there and first derivative is also there. And let's suppose we have, so del square y over del x square. And some trigonometrical functions will also be there. Let's suppose sine dy over dx. Let's take this sign. Dx equals to dy over dx, etc. The equation that will have the differentiation and equality symbol. So differential equation means differentiation will be there and symbol of equalities will be there. We have some specific points, then only we can say any equation is my differential equation. So for differential equation, we have to be very careful for the few parts. For example, some basic rule for the differential equation is the power or the degree, we can say. The differential equation, the power of the highest order, power of the highest order of derivative, power of highest order of derivative should be in polynomial. What does this mean? We'll explain. Do you know about the degree? The word degree means, or order means? Degree is the, write down. We have some word degree. So degree is the power of the highest order of derivative in polynomial. So degree is the power of the highest order of derivative in polynomial. We will use some word frequently, that's my order. The order is the highest order derivative, nothing else. So first of all, so the degree is the power of the highest order of the derivative in polynomial. Order is the highest order derivative. Means if I have del square y over dx square plus sin x equals to 0. So degree is the power of the highest order of derivative in polynomial. So we have the order. What is the order here? Highest order derivative. So this is the order we can see. Order is 2 here. What is the degree here? Whatever the exponent of this one, the highest order derivative. So here we have the order will be equals to 1 because we have the power of the like highest degree order is my 1 only. I have some equations. Let's suppose del square y over dx square and then whole power plus sine of 2x equals to dy over dx whole square. So if I'll ask you what is the order and what is the degree. So I have the order. So first of all, order, let's take 3 here. So order is my highest order derivative. So what is the highest order derivative? This is my third derivative and this is my first derivative, dy over dx, and this is my third derivative. So the order is my 3 here. Now, what is the degree? So whatever the order will be there, its power is 5 here. So 5 will be my degree. Getting my point?
Yeah.
if I have d square y over dx square, its power is 5 plus 2 sine x equals to, let's suppose 1. So what is the order here? What's the degree here?
Uh, or- order is
This is my,
2.
yes, second order derivative. So this
Yeah,
is, yes, this is called
and
as,
degree is 5.
and this degree is 5. Now some rules are there. What will be the next is, let's suppose I have del square y over square sine of dy over dx. So del square y over del dx square plus sine dy over dx equals to dy over dx, and thus power, let's take 6. Now here, what is the order and what is the degree?
The order is 2 and the degree is 5.
Now let's hear the catch. Order is 2, but we have no degree defined. Not defined. When we'll call the degree is not defined, let's try to understand. We have some rules for the differential equations. So order means the highest, like we can say the, what is this? Like the highest order derivative. That's my 2 here, no doubt. But for the degree, we have to make sure few things, that there must be no derivative in the trigonometrical function. If you'll see, we have the sine and then dy over dx. Sine dy over dx. So sine dy over dx means, see, this derivative dy over dx is in the trigonometrical function sine. So we can say that this is not my, the degree will not be defined for this kind of differential equation. So we have the rules. So the rules are, for any differential equation, if we need to discuss, so differential equation, first point, the power should be positive. First thing is this one, positive integer. Second thing, derivative should be, derivative should not be in, what we can say, angle. Means sine, and this is my theta, right? So sine and theta. So theta should not be in the form of derivative. Means sine dy over dx, if we will have, so we can say this is not my, so order will be there, two second order derivative, but the degree will not be defined. Okay. So if we have some example like this, d square y over the double derivative, power is 5 plus sine of, so if we talk about, like if we'll discuss the order and then degree. So what's the order? Order, check the order please, the higher order derivative. So what is the highest order derivative here?
order is 2, 3, 5. Oh, no, 3, 1.
The order will be 3. The
Yeah.
highest order 3. But the degree is by
5.
not defined. Why? Again, same rule. Because we have sine and then theta. In place of theta, we have derivative. In such situation, the degree is not defined. Please keep in mind. Clear?
Yeah.
Same thing. If I have del square y over dx square, power is is let's take then d. So what's the order and what's the degree here?
Order is 2, or no, 3.
Order is 3. What's the degree?
Not defined.
See,
Oh, 2, 2, sorry.
we have, right? And what's the
Yeah,
degree? Of
2.
course, 2. Yes. So that's all for the basic discussion. Now let's try to understand how many types of differential equations will be there. So now solution of first types of differential equations. Type number 1. Separate out the variables. First. Okay. So separable differential equation means separate out the variables. Separable differential equation. Type second. Homogeneous.
Wait, what? I don't,
Sorry.
can you repeat that? I don't understand.
Which one?
Like what you were saying. I don't understand
Or
the
which one?
question. Like,
Where's
did
the
you ask me a question or?
where's the question?
Oh, no, never mind. Sorry. Okay.
Okay, no. I'm telling you, like, we have the two types of the differential equation. The very first type is separate out variables. Second is homogeneous differential equation that we will learn. So first of all, you have learned, I guess, separate out variables in this school, right?
Yeah.
So separable differential equations that we need to discuss. Second type is will be that you will discuss will be homogeneous differential equation. Differential equation. Third will be linear differential equation. Differential equation. The types of differential equations are separate out variables, homogeneous differential equation, and linear differential equation. Okay. So let's
Yeah.
start with the separable differential equation, which is my separate out differential equation also. Separate out variables. First one. Shall we start?
Yeah.
So see, we will have some steps to do. Always keep in mind the question number. Let's suppose question we have is kind of we are dealing with the type number 1 means separate or separable differential equation. Separable. The very first question is we have, let's suppose sec square of x tan of y dx plus sec square x, sec square y, sec square y plus tan x and dy equals to 0. This is my differential equation, and I need to solve this by separable differential equation. First of all, see, the very first step will be find the first step. Find dy over dx. This is the first thing. So first of all, find the dy over dx from here. So we will get sec square of x. We have 10 y d, and this is my how much? This should be y. Hold on. 10x dy, and yes, perfect. So we have sec square of x and then 10y, and this is my dx equals to, shift this one to this side. We'll get how much? The equation is this one, sec square of. So negative of sec square y, tan of x, and then tan of x, and then dy. From here, we will find out the dy over dx. So dy over dx will be how much? So let's do one thing. Dy equation should be to the left hand side so that it will be easy to calculate. This expression, this will be my sec square of y, tan x dy equals to negative of sec square x, sec square x, tan y dx. Now dy will be as it is, dx will move to this left hand side, so it will become dx here equals to, so dy over dx, that's equals to negative of sec square of x, tan of y, divided by sec square of y, tan of x. So if we can, so the very first thing, if we can differentiate, or we can find out the dy over dx like this, and we can separate the variables, means we can x together and y together. As you can see here, the next step that I need to do is I need to just separate the x and y. That will become dy, and this tan y will move to this side, so tan and y, and sec square is there, so let's take sec square y here equal to, now, so dy over this sec square y will move to the left hand side, so all y should be one side, all x should be in another side. So we will have sec square y dy over tan of y, and here it should be my negative sec square of x and dx over tan of x. So sec square of y dy over tan y equals to minus sec square x dot dx over this one. Now from here, so you can see here the variables are separated out, all x together and y together. Few equations will be there where you won't be able to separate out the variables. In that equation, we will deal with the other way. But this kind of equation is my separable, which means x can be separated and y can be separated. One should be in the left hand side, one should be in the right hand side. Now, if such situation will be there, now we have to integrate. So integrating both sides. So this is the symbol of integration, you know that, sec square of y dy over dx. So sec square y over dy over, let's take tan and y, equals to, here again, minus of sec square x over, now let how to integrate this. So we usually let tan y equals to t. Differentiate this. So tan y equals to t. So now what is the? So now here from here we will get sec square of y. So because tan y differentiation is my what? Sec square of y. Now this is my d and y over, let's suppose, dx. And this is my dt over dx. So this instead of taking dx, we can take just simply any other variable. So although this will be gets reduced, so we can ignore this. So derivative of tan y will be my sec square y and dy equals to dt. Now, so here we have sec square y dy, which is equals to, so sec square y and dy, which is equals to dt. And tan y we have considered t. So this will become dt over t. Right hand side, same thing. Let sec square of x equals to, let's take, we can say z. So on differentiating, we will get how much? So let's tan x, sorry. This is tan x. What is the differentiation of tan x? Differentiation of tan x is sec square x.
Yeah.
Sec square of x, and then dx equals to dz. So that's going to be our, just replace here. So we would get integration, minus is there, dz over this tan x was my z. So dt over t equals to negative dz over z. Now integrate this. So 1 over t integration is my log t. Similarly, 1 over z is my log t. So log t plus c. Replace the t, whatever was the like we have taken. It's my log z, sorry. It's log z. So log of, what was the t? So t was tan y. Negative of log of tan x. So z was my tan x and t was my tan y. So I replaced again, and then let's solve this. So log of tan y plus log of tan x equals to c. And we know that log of a plus log of b would be log a times of b. So this is going to be my log of tan y tan x equals to c. Instead of c, let's take this log c. C can be anything according to the equations we have. The c and log c both are, because c is also a constant number. What constant number? We don't know. Log c is also a constant number. We don't know. C is something that we are taking as per the equation or as per the convenient. So instead of taking c, we can take log c also. Why we are taking this? As you can see, we have log now both sides. So log and log will be cancelled now. This is log, which will be cancelled. This one. So we would get finally tan y to tan x equals to c. And that's the solution of the differential equation we had. So all the differential equations will be of this type, means we have to use the process. First of all, we will have to find the dy over dx. After finding the dy over dx, we have to separate the variables. Once we will able to separate the variables, then we can proceed with the next step. We will integrate. To integrate, we have multiple ways to do the integration. So first of all, we have done the dy over dx. After getting the dy over dx, we have done the separate out variables. So variables are separated. You can see here, variables are separated. Variables are separated here. That's the reason this differential equation known as this variable separable. You will get some equations also where you won't be able to like separate the variables. So in that case, we will use the different method to solve. So first of all, we have separated variables. Once you will be able to separate the variables, now the integration will be an easy task. So substitute integration we have learned, like we can take 10y equals to t and then differentiate this. So you will get sec square y dy equals to dt. And then the whole equation will become dt over t minus dz over z. Now 1 over t is my log t, 1 over z is my log z. Now I have done some calculation. So this will become 10 log 10y plus log 10x. And then this is the rule for the logarithm. If we have the log a plus log b, that will become log a times b. So it become log 10y dot 10x equals to c. So now c can be written as log c also. There is no restriction for the c. C can be anything. C can be exponential, c can be logarithm, c can be any trigonometrical function. So log c we have taken because we had log here to the left hand side. Now cancel out, we will get 10y dot t 10x equals to c. Clear?